Hi everyone, my name is Vipul Raheja and I'm an applied research scientist at Grammarly. And today I'm going to talk about building intelligent and interactive writing assistants in the era of large language models. This work has been done together with my excellent coworkers and collaborators over the past year. So to kick things off, let's talk about the writing process to lay down a framework of what people do when they write. There has been extensive research done on the theory of writing dating as far back as the 80s. It describes writing as a complex and effortful cognitive task where writers balance and orchestrate three different cognitive processes: planning, translation, and revision. However, contrary to the theory, in practice, the writing process is not so simple and linear. It actually is recursive. It jumps ahead and leaps behind. And as we write anything, we may jump ahead to a later stage of the writing process, or we may revisit a prior stage. So this work focuses on text revision as an essential part of the writing process. It enables writers to deliberate over and organize their thoughts, to find a new argument, and discover what was not known before. So while text revision is a strategic and adaptive process, it's more importantly an iterative process. That's because human writers are not able to simultaneously comprehend the different demands and constraints of the different tasks when we produce well-written text. For example, expressing ideas, covering the content, following linguistic norms, and so on. And therefore, as humans, we turn towards making successive iterations of revisions to reduce the number of considerations at each time. And this phenomenon of iterative revision is the topic of my research, which I'll share with you all today. So with the advent of large language models, similar to the differences that we see in the writing process, the processes and paradigms of writing assistants have also undergone a major shift. Broadly speaking, conventionally, writing assistance has been generally system-driven or a push-based protocol where a user would type their text, the system would evaluate it against some machine learning models, and then provide a set of suggestions, which the user could accept or reject. This would go on for a few turns until the system didn't detect anything worth improving. But more recently, in addition to the prior paradigm of system-driven, click-heavy interaction, we have more user-driven systems. It's now more of a conversation with an LLM or like successive interactions with large language models, which provides a much more collaborative revision experience as opposed to the system providing prescriptive suggestions that the user had no control over. So here you can see that this interaction with the writing assistant starts even before a single word in the final document exists. The user can write the first draft like they did before, or they can now provide instructions or input what needs to be written, and the system will generate the first draft. Then the evaluation proceeds pretty much the same way, but now at the revision stage, the user can either continue revising themselves, or they can go ahead and ask the system to suggest further improvements. And if the user chooses the latter, the system can go ahead and actually even make those revisions. And this interaction then evolves like any other agent-based interaction, where it's a back and forth between the user and the system about what edits need to be made. And finally, the final document is generated. And in addition to being this back and forth interaction, the changes that the system makes are also much broader. So if we remove the older way of composing and revising text, we are left with this, which if unraveled through time looks like this, which as you can see, looks like a user having multiple interactions with the intelligent writing assistant. And the sequence of interaction spans multiple stages of the writing process, right from ideation to composition to multiple rounds of evaluation and revision. So therefore, the new paradigm of writing assistance brings with it a lot of challenges. And in reality, while we're quite far from addressing these challenges, we are still in the phase of understanding the writing process and the changing writing assistance process. And therefore, we have while there's a long way to go, we've still made some progress in the direction of understanding the first thing, which is the writing process itself. Secondly, modeling the writing writing process to provide better writing assistance. And thirdly, a setting of human in the loop collaborative revision, where from the perspective of users being able to leverage intelligent writing assistance better. And these are the main research questions that will be the focus of my talk. So now let's dive deeper into iterative text revision. So how did we approach these research questions and find gaps in prior work? So firstly, we created a generalizable edit intention taxonomy of text revision that can be applied across different domains to help understand general human editing behaviors. We use this taxonomy to collect text editing annotations with crowdsourcing. Finally, we use this data set and taxonomy to computationally model the process of text revision using state-of-the-art text editing and text generation techniques. And finally, we built a human-in-the-loop text editing system to make revision process more interpretable and efficient. And by analyzing these edits made by our text editing models and comparing them against human editing patterns, we take a significant step in understanding and exposing the challenges to computationally model this whole process of iterative text revision. Therefore, the name iterator. So as part of our focus on the first research question, which is understanding the writing process itself, in the interest of time, I'll keep the first two things short and refer you to our paper from ACL last year, where we proposed a taxonomy for text revision based on edit intents. And secondly, we collected a large-scale data set of iterative revisions in the wild. So more specifically for our taxonomy of text editing, we focused on non-meaning changing edits. And as you can see, this taxonomy of text editing, edit intentions, is generally applicable to multiple domains, multiple granularities, and multiple revision depths. So as for the data set itself, we first collected a large data set of raw documents across different domains, as they have such as news articles, Wikipedia, and so on, because they have different writing goals, different writing patterns, different editing interactions. And each document comes with its own revision history. So for each document, we sort each version according to its timestamp in ascending order. And for each document, we pair two consecutive versions as one revision. And for each document, each of these document revisions, we extract its full set of edit actions and use Amazon Mechanical Turk to crowdsource edit intention annotations according to the proposed edit intention taxonomy that I presented in the previous slides. So again, in the interest of time and for the focus of this talk, I'll refer you to the paper for the details of how we collected this large-scale data set, which gave us a foundation to understand the process and build our system on top of it. So in the next section, I will cover the various modeling approaches we explored to model the process using the taxonomy we proposed and the data set we collected. And this will simultaneously address the next two research questions. So when it comes to modeling the writing process over time, we've seen three distinct patterns which forms the body of our work. These are called system-driven, user-driven, and mixed initiative writing assistance systems. Mainly, they differ along three axes. The first one is initiative, defined as who, interaction or initiative, defined as who out of human and machine drives the revision interactions. Second one is revision, defined as who performs the revision. And the third one is evaluation, defined as who evaluates the quality of the revised text and drives the next step in the interaction. So our first work, called Deliterator, is quite system heavy, with the user driving only the evaluation by accepting or rejecting the edits proposed by the writing assistance system. We followed it up with another system called Coedit, which is mostly user-driven. We leverage instruction tuning to enable the user to drive both the interaction and evaluation. And finally, we proposed a more balanced and collaborative system called CTRLHF, where we leverage both human preferences to empower, both the user and the system collaboratively to drive the revision process, which enables a much higher quality of revision experience. And a small thing to note is that the machine will always be a primary driver of the revision by definition. And these are the three modeling systems that I'll dive deeper into going forward. So let me first describe the system-driven model called delineate and edit iteratively, or deliterator. So here's a bit more detail on how we model the system-driven writing assistants. We propose a two-step approach to text editing, where we first perform edit intention classification, where we first predict the spans in a given piece of text that need revision, uh, and that which is by edit intention, which could be one of fluency, clarity, coherence, and style, according to the taxonomy we proposed earlier. And then for the predicted spans that need revision, a text revision model, which is typically a fine-tuned large language model, makes the actual edits, which leads to a new document revision. And so here we see that given a document with, let's say, n sentences, we take a context window of k sentences. It's shown here with k as 2. So every two sentences, for every two sentences, we predict the spans that need revision and the type of revision needed by edit intention. And then for the predicted sentences or spans that need revision, a text revision model will actually make the right edits, leading to a new document revision. And this process will repeat or continue till for a few iterations, till the system predicts that there are no more revisions to be made, leading to the final version. So as you can see, this is predominantly system driven, and the user was just able to maybe select in a real world setting. The user might just be able to accept or reject the suggestions made by the model. But now I will describe the user driven model called co-edit, or collaborative text editing through instruction tuning. And you can see in this work, we explored the other end of the spectrum, where we have the full control of we gave the full control to the user to drive the revision process. And as you can see, over many iterations, the revision interaction, the revision itself, and the evaluation, all of these are driven by the user, where the system is just sharing the main responsibility of the revision. So in co-edit, we replace the automated system-driven edit intent detection and revision with a more user-centric interaction, where the user can provide instructions in natural language, and the revision model, which is an instruction-tuned LLM, can perform the edits. And note that the user can also make the revisions here. So the revision interaction, revision itself, and the evaluation, all of these are driven by the user, where the system is sharing the main responsibility of actually performing the revisions. Now, one can argue that this is the other extreme, from being mostly system-driven to mostly being user-driven here. And due to the iterative nature of the process here, it comes with a bunch of challenges related to context management and evaluation and so on. So now we finally came up, looking at both these two extreme formulations, we came up with CTRLHF, which tries to address the limitations of both the previous systems pertaining to interaction, revision, and evaluation, where all the three aspects are a collaboration between the human and the machine. And as you can see, every stage has both human and machine responsible for driving it. So the user can provide some input about what text to write. Both the human and machine can collaborate on what gets generated, and the human can edit it. Then the user will drive maybe the next interaction, and this will keep going on. Or the system can suggest the set of next steps to be taken. So again, the interaction and evaluation both are being driven by both the model and the user collaboratively. And so if we look at a more simplified version of CTRLHF in the context of the old architecture diagram that I've been sharing, In CTRLHF, given a document in the revision cycle, which could have been created by a human or in collaboration with a text generation system, we replace the predominantly user-driven interaction with a more collaborative system. Now, the evaluation can be done by both human and machine, and they can collaboratively decide the next steps in the revision process. And as I mentioned before, we do it in two different ways. The first one is by improving text editing models using RLHF, which is this part, but also um, having this text quality evaluator, which under the hood uses large language model ensembles as quality evaluators, where we leverage different large language models to first understand the quality of a given piece of text and then suggest a set of improvements that can be made. So both of these works are under review, but hopefully they will be publicly shared soon. And in this way, we are able to introduce collaboration in all aspects of the system. So in the next section, I will present some results pertaining to the modeling and human-machine collaboration. So across our modeling and human-machine collaborative writing explorations, we observed that while instruction tuning has been an incredibly powerful technique to improve the quality of revisions, RLHF training is able to improve it further, especially along the more subjective criteria such as style and coherence. In contrast, we also conduct experiments against ChatGPT while it's able to outperform our systems on style and fluency tasks, it lags much far behind on coherence and clarity tasks, which can be attributed to the verbosity or more creative editing, which could be good for paraphrasing, but not so good when it comes to correctness. And at the same time, we can see that our models are able to do this while being much smaller than ChatGPT. And again, I'll refer you to our papers for all the results. Secondly, we also conducted qualitative human evaluations by asking qualified users to use our system for iterative revision using different models at the backend. And we found that in terms of human evaluations, the ratings were in line with the automated metrics, where CTRLHF did better than Coedit, which did better than Deliterator. But however, ChatGPT scored quite close to the CTRLHF, which was better than the automatic evaluations. And this indicates the limitations of automatic metrics and that there's a huge need for better document level evaluations of text editing. So finally, we also measure the efficiency of the mixed initiative by removing the human interaction from our system and asking 3 qualified annotators again to evaluate the revisions made by our system for a few hundreds of documents, which had at least 3 revisions per document. And this gives us the system-only baseline. And the annotators were asked to judge whether the final revised documents have improved in quality. And the results show that human-machine interaction helps produce higher quality of revised documents with fewer number of edits, and fewer iterations of revisions on average. So that this validates the effectiveness of our human feedback in the revision process, which can help filter out noisy edits and improve the quality of the final revised documents. And one interesting insight is that mixed initiative setting led to a slower revision process, which means that while the amount of work was reduced, it still made people slower as they had to evaluate the system's suggestions more, which was a pretty interesting finding. So to summarize, our proposed systems demonstrate improvements in terms of quality, effectiveness, and efficiency of writing assistance, which are kind of the 3 pillars which we evaluate the progress that we're making in terms of providing more effective writing assistance. So our computation modeling of the process of iterative text revision has progressively gotten better, owing to the advances in text generation and large language models, as we saw in the evaluations. And we find that human-machine collaboration works much better than any of the other extreme alternatives that we saw. as that skew the control of interaction, revision, and evaluation to either party. And finally, while collaborative revision improves user quality of writing, it also leads to slower revision. So there is some scope of improvement there. So, which brings me to this slide about future work. So, we aim to improve the contextualization of our systems to make them provide better suggestions for different users and different writing needs. We hope to invest some effort in formulating better evaluation frameworks to address the gaps in evaluating the tasks of iterative revision, accounting for document level quality, revision history, user preferences, and so on. And finally, we aim to improve this human in the loop writing process by learning to provide the most effective suggestions. Finally, I'd like to leave you with some examples of how we are leveraging this research in the Grammarly product. The first one is Grammarly Go, which is Grammarly's large language model powered offering, which is generally available. And as you can see, these are some examples of how we can use our products for composing, revising effectively. And secondly, the other one is a version of this on mobile, where we leverage speech as users' input to articulate what they want to write about. And we give them the ability to compose and edit documents, messages, or notes, all with their voice, which makes the writing experience convenient and easy to use on the go. Voice Composer is generally available on iOS. And that's it. Thank you so much, everyone.